All right, so let's solve these problems. In the first problem, you are given a square matrix A, and you are asked to write a statement that will select the first two rows and the last three columns. So when I have a matrix whose size I do not know beforehand, and I know it has at least 3 rows and 3 columns, you want to index the first 2 rows, and you don't care how many other rows it has. And we want to index the last 3 columns. So we want to refer to this section right here. The first 2 rows will be 1 and 2. So I can provide a vector for the rows that I'm referring to, the first and second row. And then similarly, I need to provide another vector that will give me the last 3 columns. And that will be n minus 2, colon, n. Note that it's not n minus 3, because if you start from the last one, which is n, the one before that will be n minus 1, and the one before that will be n minus 2. Doing n minus 3 was a common mistake. All right? You can replace this vector with 1, colon, 2. Okay? Some of you have assumed that the matrix was 3 by 3 and just wrote 4 to 6 here. So that's not going to be correct. You want your code to work for any matrix A, regardless of what its size is. All right, any questions? Okay, the second problem, we have a matrix M that contains 5 rows and 8 columns. And we want to convert this row and column indexing to a linear indexing. In MATLAB, matrices are stored column-wise, meaning the first column comes first, and then the second column comes after that. So let's just draw this matrix. Matrix M has 5 rows, 1, 2, 3, 4, 5. And it has however many columns that I don't really care, 8 columns. So we want row number 4, this one, and column number 3. Okay. So we will start from the first column and start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is the cell that I am indexing because of the 4th row and the 3rd column. All right, so the answer is 14. You can figure out a more general equation for this. As you can see, I went, how many columns did I go through? How many full columns did I go through? Only 2, right? I went through 1 minus the column that I'm indexing. Sorry, the number of columns that I'm indexing minus 1. That's how many full columns I went through. And each full column contains the number of rows in my matrix. So if I have the number of columns C, and I'm trying to index I, comma J, J is the column I'm indexing. Let's say my matrix contains R, comma C, R rows, C columns. I'm going to multiply R with J minus 1. I'm going over J minus 1 full columns, each full column containing R elements, and then plus the column number that I'm referring to. So I'm going over 2 entire rows, or 2 columns, and then in the last trip, I'm only going to the 3rd one. Make sense? If you plug in these numbers, R is 5 times J is 3 minus 1 plus 3, that'll give you 13. And then since this equation is based on 0, you always have to add 1 more, so that'll give you 14. So the equation is R times J minus 1 plus J plus 1. That make sense? Okay. Next problem is about creating vectors using step sizes. The first problem is asking you to use the colon operator. So some of you have answered as follows. You said minus 10 colon 5 all the way to 15. This will give you a vector, but not the vector that we want. This will give you minus 10, minus 5, 0, 5, 10, 15. What we want is the vector to start from 15. So your first entry will be 15. And then the step size is by how much you would like to increment starting from the first entry. And since we are decrementing, our step size will be a negative number. It will be minus 5 all the way to minus 10. So we are starting from 15, adding a step size of minus 5 each time until we reach minus 10. And this will give me this vector in the question. All right? What would happen if I said 15 colon 5 colon minus 10? What vector will that result in? So what vector will I get? I'll still get an answer, right? It'll still give me a vector. So what will that vector be? So if I start from 15 and increment by 5 until I reach minus 10, I will never get there, right? Because I'm already above that. So MATLAB will give you an empty vector, a vector that contains no elements. All right? Okay. In the second part of this question, we are going to generate the same vector using linspace, which helps us generate equally spaced numbers. And you first type in the number that you are starting from, which is 15, the number that you are ending with, minus 10, and how many numbers you are generating. We have 6 numbers here, so we want to generate 6 numbers. All right? Okay. Any questions? Next problem, logical indexing. So this is very similar to the Pythagorean problem that you guys solved in the, or I think I solved during class, and you also had to solve it as a homework. We have 3 vectors, 3 column vectors, x, y, and z. We want to construct a vector I that will have the same size. And it will satisfy 2 conditions, one of them being x multiplied by y equals z, and the other one being x is smaller than y. So all you have to do is say dot multiply, since we want to do element-wise multiplication. We do not want to do matrix multiplication. And then say equal, equal. All right? So this will be I equals x dot multiply y equals z. This will generate a vector I that has the same size as x and y, and it will contain 1 wherever there's a corresponding entry in x, y, and z that satisfy this equation. All right, the next condition that we would like to meet is that x smaller than y. So we will add this condition with an end expression. X smaller than or equal to y. All right? So let me rewrite this. X dot multiply y equals z, and x smaller than or equal to y. After we get this vector I, we would like to use it to construct a matrix M that picks out the rows of x, y, and z that satisfy these conditions, meaning you want to pick out from x, y, and z wherever you have a 1 in I. So if you want to pick out values of x that satisfy these conditions, you would say xi. Similarly, you would say yi and zi. Each of these will give you a new vector extracted from x, y, and z. Then we will combine them into a single matrix and say M equals that. All right? Another solution that involves two steps. So this question asks you to do it in a single line. Another way to do it is to first construct matrix M and just put x, y, and z in it. So x, y, and z are three column vectors. You are combining them into a new matrix that has as many rows as x, y, and z had and has three columns. And then from this matrix M, you can pick the rows that satisfy the conditions that we have in this question, comma, all columns. We want to pick out all three columns from M, but only those rows satisfying the condition. All right? Any questions? Bless you. Let's move on to the next problem. A lot of you got this one right. So we have a function called apple that takes an input argument x and returns an output argument y. The key point in this problem was to note that the variables in the workspace, in the command window workspace, where you have also variables x and y, have nothing to do with the variables inside the function, except when they are being passed to it, in which case the value inside the variable is being copied to the function variable, but the original variable does not change when you change it inside the function. Okay? So let's draw boxes. Whoop. So I'll have one box for x inside the function and one for y. And for the workspace, I will have also x and y. And then also a and b. So this is x, y, a, b. Initially, x was equal to 5, so let's store 5, and y equals 6. And now I'm calling apple function with the value of x being taken and copied into the function's variable x. So now the function's variable x contains 5. And then function calculates a new value for x by multiplying it with 2. So this will become 10. And then in the second line of the code, I'm multiplying x again with 2, but storing the result in y. So y will become 20. And then this value of y is being returned from the function back to the caller, where I'm storing it in variable y in the workspace. So this command window workspace variable y will become 20. All right? Next, I'm performing the same thing for a equals 2 and b equals 3, right? I can see it on this window. So let's repeat it. X, y. You take 2 copied into the x variable. You multiply it with 2, it becomes 4. You multiply it with 2 and store it in y. Y becomes 8. You take y and store it in b. So b becomes 8. And then the printf statement prints x equals 5, comma, sorry, there's no comma, y equals 20, and a equals 2, B equals 8. Okay? Any questions? All right. Let's move on. Nested for loops. It helps to draw boxes and keep track of the values for your variables. I have two variables that control the loops, one of them being A and the other one being B. So the values for A will be 1, 2, and 3. The values for B will be 4 and 5. When you first enter the outer for loop, the first value of A will be active. So let's put it inside the box, 1. And then I'm moving into the second for loop. The value of B will be 4. And then I'm constructing a vector from the values of A and B. So this vector will contain 1 and 4. And what do I do with this vector? I add it to the end of X. The variable X is a matrix constructed with the zeros function. It has 2 rows and 0 columns. So let's say it has 2 rows but no columns yet. Okay, so it has 0 columns. This expression X colon says that I'm referring to all rows of this X. So I'm referring to both the first and second rows of X. The AND statement, the AND keyword, will be replaced with the number of columns X has. So if you have an AND keyword that's on the right-hand side of a comma, it is replaced with the number of columns. If it is on the left-hand side of a comma, it's replaced with the number of rows in that matrix. In this case, I currently have 0 columns in X, so X will be 0. So essentially, I am doing this, X colon, comma, 1 equals 1, 4. So I'm referring to the first and second row and the first column of X and placing this vector 1 and 4. So 1 will go into the first box, 4 will go into the second box. All right? Okay, so I'm done with the first iteration of the inner for loop. Then it'll go and try the other value of B, which is 5, and repeat the same thing. A still contains 1, and we will get 1, 5. I'm done with the inner for loop and have consumed all of its values. I will iterate over the outer for loop, take the next value, which is 2, repeat the process, 2, 4, 2, 5, and repeat the process again for the third value of the outer for loop, which will give me 3, 4, 3, 5. And when you display this matrix X, you will get 1, 1, 2, 2, 3, 3, 4, 5, 4, 5, 4, 5 as the output. Any questions? All right. Let's move on. The next problem is about operator precedence. So we have smaller than or equal to signs. We'll just start from the leftmost one. And it's a binary operation. You take 2 numbers and generate a new number. Actually generate true or false. -3 smaller than 0 will give you false. So this will be 0. And then 0 smaller than 3 will give you true, and it will be displayed as 1. So the answer to this question is just 1. The problem on the right, you need to know that arithmetic operations are performed before relational operations. So the addition comes before equal sign. D plus 1 will give you a numerical representation for the letter E. And then E equal E will give you true, which will be 1. Question?
So for the first one, even though part of it is false, because the second part of it is true, it makes the whole thing true?
So for the first question, it's not that the first part is 0 and the second part is true. It makes the whole thing true. You need to consider each operation individually. So this is, and then replace the entire operation with its result. So this evaluates to 0. So this entire expression should have the same result as saying 0 smaller than or equal to 3. All right?
So if that was negative 3, then it would be false.
If x was negative 3, you mean?
If 3 is negative.
If on the right, this one is negative 3?
Yeah.
Yes, then it would be false. So you just take 2 at a time, evaluate it, replace those 2 numbers and the expression between them with its result. And then you have a new expression to evaluate. So at each step, you take 2 arguments, get the result, replace the original expression with its result, and then move on. All right? So it's the same thing that you do with addition and subtraction and multiplication. When you have 5 times 2 plus 2 times 3, you take 5 times 2, you remove it, replace it with its result. You take 2 times 3, you remove it, and replace it with its result. And then you operate on what's left. Okay, it's the same idea. Okay? All right. The next problem, we will convert binary numbers to decimals and also hexadecimal numbers to decimals. So let's see what number 35 is written in binary format. The largest power of 2 is 32. So that's 2 to the power 5. And then you have 3 will be remaining out of 35 because we took care of 32. The largest power of 2 in 3 is 2 to the power 1. And then we took care of 2 out of it. We will have 1 remaining. The largest power of 2 in 1 is 2 to the power 0. So we took care of all the numbers we had. And this will add up to 35. And you can take the powers to construct your binary number. 0 corresponds to the first box on the very right. So we have a 1 here. And then we have a 1 in the second box. So this is 2 to the power 0s, 2 to the power 1s, power 2s, power 3s, power 4s, and power 5s. Okay? And you will place a 1 wherever you have a power in your addition. And everything else will be 0. So the answer is 1, 0, 0, 0, 1, 1. Okay? The last problem is a hexadecimal number. The 0x at the beginning of it just means that it's a hexadecimal number. All right? It does not have any numerical value. It just means that this number is a hexadecimal number. And we had examples of this in the first lecture. Hexadecimal means 16, base 16. So each digit will be base 16. We have only 2 digits. The first one will be 16 to the power 0. The second one will be 16 to the power 1. And inside the first box we have 3. Inside the second box we have f. Since we have only 10 digits, the values after 10 are denoted with A through F. So A is equal to 10, B is 11, C is 12, and F is 15. So the result of this is 15 times 16 plus 3, which gives you 243. Okay? Questions? All right. In the first programming problem, you are asked to write a function that will tell you whether a matrix is a magic square. So you have to identify what checks you need to perform in order to claim a matrix to be a magic matrix. Let's open MATLAB. So this function takes a single matrix and returns a logical number. Let's call it y, is magic m. We first need to check that this is a square matrix. So let's take the number of rows and number of columns equals size of m. Let's set the output value to be 0 first, or false. And then if all of the conditions are met, we will convert it to true. If at least one of the conditions is not met, it will remain false. Okay? So let's first check if R equals C. So MATLAB will enter into this if statement only if R equals C, meaning the matrix M is a square matrix. All right? The next thing we need to check is whether the sum of rows equals the sum of columns. Let's check the documentation for sum. You provide the matrix and it gives you the sums of rows, I believe. Let's try it in the command window. So sum of 1, 2, colon, 3, 4. And you get the sums of columns, apparently. There's a second argument that you can provide. If you provide 1, it will give you sums along each column. If you provide 2, it will give you the sums along each row. All right? To get the sums along each row, you can also provide the transpose of your matrix. So it will give you the same result. I mean, the same result transpose. So what we need to do is check that sum of M equals sum of its transpose. All right? And then we want to make sure that they all add up to the same number. So if you say unique, let me actually do it this way. And then we have to say all, because this expression will give you a vector. You want to make sure that they are all ones, meaning they are all trues. The equal sign is true for all of the entries in this vector. All right, so let's do it in the command window. Let's say M equals that. Sum of M will give you 4 and 6. Sum of M transpose will give you 3 and 7. Sum of M equals sum of M prime will give you falses, right? We are looking for those entries to be true, so we need to use the all function. All right. MATLAB will also work as you want. If you omit the all and just provide the vector of logical values, it will only enter the if statement if all of the entries in this logical vector are true, which is the same thing as saying all. All right? The next thing we need to check is that the matrix M has unique entries, meaning all the numbers should be different. So if you take the function unique, it'll give you the unique elements of a matrix. So let's test it in the command window. Unique 1, 1, 2, 2, 3, 5 will give you 1, 2, 3, 5. Okay, so it will omit replications. It will only give you one of each numbers occurring in the input matrix or vector. If you provide a vector, if you provide a matrix, it will give you a vector. Okay. Now, how can I check that the numbers included in the matrix are all different? If you take the unique, you should get the same number of elements as the size of the matrix, as the number of elements of the entire matrix. Make sense? So if I say numel unique M equals number of elements in M, this equation will be true only when all of the numbers in M are equal. All right? Okay. Another way to perform this check is to sort the vector or sort the matrix. Let's linearize it, so we work with a linear vector. And then say equal 1 all the way to r squared. So this, on the right-hand side, I have numbers from 1 to r squared, which is the number of elements in the matrix. And on the left-hand side, I have the matrix elements sorted. So it will be so this equation will only be satisfied if matrix M contains numbers 1 through r squared. Make sense? So is, let's say, 2. And M is equal to 1, 2, 3, 4. All right, so I'm comparing a row vector with a column vector. It's easy to fix. You can just transpose one of them, and then you will get ones if the condition holds. Let's change it to 3. Now you will have at least a 0. So let's use this idea. If you have numbers that are different, and is there anything else that I need to check? I think this should be all the conditions that I need to check. And then if so, I will set y to be equal to true. And the problem should be solved. All right? Any questions? Let's test it. Is magic 2, 2, 2, 2 should be false because the numbers are not numbers from 1 to n squared. If I say magic 4, which will give me a magic square. So it's that matrix that you see, and the answer is 1. If you provide a non-square matrix, it will never get passed into the first if statement. 1, 2, 3, 4, 5, 6, and the answer should be 0. All right. It doesn't matter. It doesn't really matter in what order you check some of these expressions. So you can move this if to outside. One problem with that is if your matrix is not square, you will have different number of elements on the left-hand side and right-hand side of this equal sign. So let's first ensure that it's a square matrix. But you could move this before the other if statement. If you have if statements inside each other, you can combine them into a single if statement using AND operation. So let's do that. So we want R to be equal to C, and we want this condition to be satisfied, and we want this condition to be satisfied. And if all of those are true, I'm going to set Y to be equal to true. All right? A further reduction of this example is that you do not really need to have an if statement. The result of this expression is the result that you are looking for, right? So if that expression is true, the function should return true. If that statement is false, the value of Y will be false. So the result of that expression itself should be the output of the function. So we can further simplify this function by saying Y equals that. And Y will only be true if all of these conditions are satisfied. Okay? Any questions? All right, so let's move on to the last problem. I will upload these solutions to the web. Let me do that now. In the last problem, you are asked to write a function that will approximate the Euler number using this expression. And you are given some hints to use the sum function and the factorial function. Edit Euler number. So let's first solve this problem using for loops, and then we will solve it without using for loops. Function Y equals Euler number n, or let's just say E equals Euler number n. I will start from 1, so let's say sum equals 1. And then if you look at the bottom part of each fraction, you can see that they start from 1, then 2, all the way to n factorial. I will have a for loop, I equals 1 all the way to n. And at each of these, the iteration of this for loop, I will add to the value of sum 1 divided by n factorial. And the function to generate a factorial is the factorial function. And this will solve the problem. All right? And then you could say E equals sum, since E is the variable that you are trying to return. This is a little bit redundant. If you are going to return E anyways, why not replace the sum with E, and then you don't need to copy it into E. Let's test it. Euler number 0 will be 1, 1 will be 1, 2 will be 0.5. Is that correct? Oh, my bad. So when at each iteration, you want to add this to the current value of E. So you want to add up those numbers. Right now, what I'm doing is I'm taking the result of the right-hand side and I'm overriding whatever I have in E. So you need to replace that with E plus that expression. So you are adding up at each iteration of the for loop. So now I get the correct number. And then number 4 is 2.70. Okay? All right, so now let's change this problem so we use vectors. Before I do that, you could also start from 0, and then you would also start from I equals 0 all the way to n. Since this first one can be rewritten as 1 over 0 factorial. Okay? All right. So this is the vector that I need to work with. the factorial function, in addition to taking a single scalar value, can also take a vector. So 0, 1, 2, 3, 4, and it will generate a new vector, which is the factorial of each of those elements. And you can see that by looking at the documentation for factorial. Okay. So for scalar n, and then n-dimensional array of each element of n. All right. So factorial 3 gives you 6. Factorial 3 and 4 gives you the factorial of 3 and factorial of 4. All right. So I have this vector, let's say n equals 4. I equals 0 all the way to n will give you numbers from 0 to 4. And then I can take the factorial of that. It'll give me the factorials of each one of those. I can divide 1 by that to get individual terms that I'm trying to add up here. But the problem is that I don't want to do matrix division. I want to do element-wise division. So 1 divided by the factorial, 0 factorial, and then 1 divided by 1 factorial, and so on. Okay. So this term will give me 1 divided by each of these elements. Once I obtain those, I can add them up by wrapping them into the sum function, which will give me the addition of all of those numbers. Let me take this, put it into my function. E equals sum of those numbers. And the problem is again solved. Any questions? All right.